Dalam dunia akhir zaman ini, betapa situasi kita diuji. Teman, manusia terus buntu, kebenaran tak bersatu, dan agama direndahi dan dihina. Kita terus bergaduh sama sendiri, musuh bersatu terus menghanturi, hingga kita terus lanjut dengan dosa tanpa rasa. Keliru hati dan arah tuju.
Kadang ku bertanya pada diriku, sumbangan apa yang ku mampu laku, cara apa lagi yang terbaik teman. Oh yeah, mungkin kau rasa ini semua normal, kamu kira saya tak kami persoal.
So, as you can see the question before, it is related to the dimensional analysis. Before I explain about the solution for the question, I will explain about the dimensional analysis. Okay, what is dimensional analysis? It is to generate the non-dimensional parameters that help in the design of experiment, physical and or numerical, and in the reporting of experimental results. And it is to obtain the scaling laws so that prototype performance can be predicted from model performance. And the third is to predict trends in the relationship between parameters, concept of dimensional analysis, which is there are three principles of similarity, which is first geometric similarity, second kinematic similarity, and the third is dynamic similarity. Okay, so the Reynolds number is the most well-known and useful dimensionless parameter in all of fluid mechanics. Okay, so we go to the question. From the question we get the temperature, which is the density is here, length of the prototype, the mu prototype is here, and also the information for the model, temperature, velocity of the model, length, and the mu for the model. Okay, so as you can see here is Reynolds number for model equals to Reynolds number of prototype. So Reynolds number equals to rho times V times L over mu. Okay, model is equal to the prototype. So we have to find the velocity of the prototype. So we can substitute all the information in this formula, and we can get this 2.5 km per second. So this is the velocity of the prototype in the air. Okay. So next, I will explain about the method of repeating variables. Okay. It is used to generate the non-dimensional parameters. So it is a step-by-step procedure or receipt for obtaining non-dimensional parameters. Okay. First step, we must list the parameters in the problem. Second, list the primary dimensions of each of the parameters. And third, set the reduction as the number of primary dimensions. Fourth, choose repeating parameters. Number 5, construct the k, its, and manipulate as necessary. And the last is write the final functional relationship and check the algebra. So I think that's all from me. Thank you.
Assalamualaikum and hi, my name is MOHAMAD Rashdan bin Ahmad Yusof, message number 194194, and today I would like to talk about dimensional analysis. Okay, firstly, what is dimensional analysis? Dimensional analysis the purpose of dimensional analysis is to generate a non-dimensional parameter to help in design of experiment. Okay, it is also to obtain scalar laws so that the prototype performance can be predicted from the model performance, such as the lift, the drag coefficient, the force drag, and something like that. Okay, there are three types of similarities. The first one is geometric similarities, kinematic similarities, and dynamic similarities. Okay, next we will go to an example question for more understanding.
Bukan mudah, namun bukan alasan berpaling tada. Walaupun kau kau ditentang kau terus tabah.
Okay, this is the solution of the question. As we can see, these are the information that has been given in the question. So we can see the temperature, we can see the length, we can see the rho or the diameter, we can see the dynamic viscosity, we also have velocity, and from this information we generate, we use this formula, that is Reynolds number formula. So this is the equation. The Reynolds number of model will be equal to Reynolds number of the prototype. So Reynolds number formula is rho VL over mu. So it's also the same for the Reynolds number for the prototype. So from this equation we derive this equation to get the velocity of the prototype. So we substitute all the information in the derived formula, so we can see the answer for this question. The velocity is 2.5 kilometer per second. Okay, this is for the more understanding about the dimensional analysis. Next, I would like to talk about the method of repeating variables. The method of repeating variables is to generate the non-dimensional parameter that we have that we use in the dimensional analysis just now. Okay, there are a few procedures or steps that we must follow to generate the non-dimensional parameter. Okay, the first step is list the parameters in the problem and count their total number that represent as n, and list the primary dimensions of each of n parameters. The third step is set the reduction j as the number of primary dimensions. Calculate k, the expected number of each k equal to n minus j. Step 4, choose j repeating parameters. And the fifth step is construct k, each, and manipulate as necessary. And the last step is write the final functional relationship and check the algebra. Okay, that's all from me. Thank you.
Jangan terpesona, jangan putus asa, terpengaruh fata murka.
Assalamualaikum warahmatullahi wabarakatuh. My name is Muhammad Zahfiq bin Muhammad Zahfiq, and my matrix number is 192006. Okay, so right now I am going to explain about dimensional analysis. So dimensional analysis is used to generate non-dimensional or dimensionless parameters that help in the design of an experiment. So it is also used to obtain scaling laws so that prototype performance can be predicted based on the model performance. And then it also help to predict trends in the relationship between parameters. So we need to understand the concept of dimensional analysis, which is the principle of similarity, before we can apply it, which is geometric similarity, kinematic similarity, and dynamic similarity. Alright, so to understand more how to apply this dimensional analysis, we are going to show how to solve an example.
Segeralah kau pinta pada yang nesa. Oh, tidakkah kau perlu?
Alright, so based on the example problems, this is all the information given, which is the temperature for the prototype, and the value for this T is taken from the table. So we have all the information for the prototype and for the model. So we are going to use Reynolds number. So given that the Reynolds number for the model is equals to the Reynolds number of the prototype, so we derive the formula so that to find the velocity of the prototype, and then we substitute the value given, and we get the value for the prototype is 2.5 km per second. So next, I'm going to explain about a method called a method of repeating variables. So this method is used to generate the non-dimensional parameters it is a step-by-step procedure or recipe for obtaining non-dimensional parameters. So the first step is to list the parameters in the problem, and the total number is equals to n. And next, list the primary dimensions of each of the parameters. Next, set the reduction as the number of primary dimensions. Calculate the expected number of the pies, which is k equals to n minus j. Next, choose j for the repeating parameters, and then construct the k pies and manipulate as necessary. And then the last step is write the final functional relationship and check the algebra. So that's all from me.
Pinta pada yang nyesal. Oh, tidakkah kau berduka melihat rumah ini terus dipenjara dengan dipenjara dengan musuh. Sinari batu di arah semua berleluasa. Dosa kecil, dosa besar. Bagi mereka saja.
Start 2, 1. Booster ignition and liftoff of the Space Shuttle Discovery, returning to the space station, paving the way for future missions beyond.
Bukan untuk mengejar pujian dan nama yang menuntut arah pulang sevisi sana dan ada tak jaga pandang.